Hello everyone, welcome to Shon's classes. In today's class, we are going to discuss a chapter, Similar Triangles or Triangles, which is chapter 6 of class 10. In this chapter, we are going to discuss the exercise 6.5. In this exercise, we are going to deal with a few problems in the beginning, 1, 2, 3, in this particular video. And in the next video, we'll discuss the rest of the examples. So, if you look at this exercise 6.5, you will realize that there are basically two concepts over here. First, we'll discuss the concept and then we'll try to dive into the problem. Okay, so let's say you have a triangle ABC. Which is right angle at 90 degree. So, from Pythagoras theorem, we know that AB square plus BC square equals to AC square. Even the converse of the theorem is, it's more like if angle B is 90 degree, then this is true. And the converse of the theorem is if AB square plus BC square equals to AC square, this implies angle B is 90 degree. So this is first, this is second. And most of the problems will be dealt with using these two theorems. So let's start with this first problem. It is saying that sides of the triangle are given below. Determine which of them are right angles. In case of a right angle triangle, write the length of its hypotenuse. So there are three sides which are given. We need to figure out whether it's a right angle triangle. So what we need to do, we have to see here that there will be a side which will be bigger than other two sides. And invariably, if it is to be a right angle triangle, this side, the bigger side, will be the hypotenuse. So we'll have to figure out, we'll calculate the other two sides and the squares and then see whether it is equal to the third side. So in either way, you have to calculate all the sides. So we will assume that AB square equals to 7 square, which is 49 in the first example. And then BC square equals to 24 square, which is 576. Now, when you add AB square plus BC square, it will be 49 plus 576, which is nothing but 625. And when you calculate this 25 square, and we'll call it AC square, then it will be 25 square, which is nothing but 625. So in this case, what will happen here is that AB square plus BC square equals to AC square. This implies that angle B is 90 degree. So yes, this is your first problem. Now let's take the second one. So as we said, the smaller sides will take as AB and BC. So we'll take AB and BC like this. So we'll take AB square equals to 3 square equals to 9. And then similarly, we'll take BC square equals to 6 square, which is nothing but 36. Now we'll calculate AC square, which is nothing but 8 square, which is 64. So when we sum up AB square plus BC square, we'll get 36 plus 9, which is 45. So we can see here that AB square plus BC square is not equal to AC square. We can write AB square plus BC square is not equals to AC square. So this means that angle B is not 90 degree. Coming to the third problem, again we'll take the two sides, the smaller sides of AB and BC. So we'll take AB equals to 50, and so AB square becomes 50 square, which is nothing but 2500. Similarly, if I take BC square equals to 80 square, which is nothing but 6400. We'll take AC square equals to 100 square, which is nothing but 10,000. Now when we sum up AB square plus BC square, we'll get 2500 plus 6400, which is nothing but 8900. So again AB square plus BC square is not equal to AC square. So this implies angle B is not equal to 90 degree. Now coming to the fourth problem, which is again 13, 12 and 5. So we'll take the two smaller side 5 and 12. So we'll take AB as 5, BC as 12 and AC as 13. So what we will get is AB square, which is nothing but 5 square equals to 25. We'll get BC square equals to 12 square, which is nothing but 144, and then we'll get AC square, which is 13 square, which is nothing but 169. So we'll get AB square plus BC square equals to AC square. This implies angle B is 90 degree. Alright, so yeah, in this way we can say that first and fourth are right angle triangle, and we had to find length of hypotenuse in each of the cases. So we can say that length of hypotenuse in this case A is AC is hypotenuse, and that's 25. And in the other case we have again AC equals to 13. So this is my hypotenuse. Okay. So these two are my hypotenuse. In other cases there is no hypotenuse, right? So yeah, we are done with problem 1. Now we'll go to problem 2. Problem 2 talks about PQR is a triangle, right angle at P, and M is the point on QR such that PM is perpendicular to QR. So show that PM square equals to PM into MR. So let's first make a right angle triangle here. So this is my one side, this is my another side, this is my third side. So we'll call it A. Oh, sorry, we don't have to call it A. So PQR is a triangle right angle at P. So P is here, a right angle at P. Then we have a Q, then we have a R. Such that now M is a point on QR such that PM is perpendicular to QR. So now there is a perpendicular drop from here to the other side. So we'll take another line which is perpendicular, right? And so now this is perpendicular and this point is M. Now PM is perpendicular to QR. So that PM square, we have to show this PM square is equal to Q1 into MR. PM square equals to Q1 into AR. So can we write PM square as PM by QM and this MR by PM? Can we write this like this? So what we have done is we have sent one PM to the other side because it's a cross multiplication. So now when you look at this, you get some idea. When you are looking at it, it's PM and QM. So PM is here and then QM is here. When you look at MR is over here and then PM is over here, right? So looks like we are talking about this triangle and this triangle, right? So we got to go into these triangles and then see whether these can we get something out of these triangles. So we have learned that if there is a right angle triangle and we draw a perpendicular like this, then what we get is this triangle is similar to the bigger triangle. This smaller triangle is similar to the bigger triangle, as well as these two smaller triangles are also similar. That is what we have learned earlier. So using this similarity condition, we know that triangle triangle PMR is similar to triangle PMQ. When we have this similarity condition, what we can see over here is that we can have the sides like PM, which is opposite to this angle R. So PM is to, in this triangle, this PM is opposite to this angle. Now we got to see that which side we should be taking as the opposite side, right? So before going there, what we can do is that, assume that this is my angle theta. Let's assume this is my angle theta. What we can write over here is, this is my 90 degree minus theta. Why so? Because in this triangle, all three angles will sum to 180 degree. So this is theta, this is 90 degree. So this is 90 degree minus theta. Since this angle is 90 degree minus theta, this angle will be theta, because overall this angle is 90 degree, right? Since this angle is theta, this angle is 90 degree. So this angle is 90 degree minus theta. So now we can say that this angle R is equal to basically P angle, right? So when we have taken a side which is PM is opposite to 90 degree minus theta angle. So we have to take a side which is opposite to 90 degree minus theta, which is going to be this side. So we have to take PM is to MQ. Similarly, we have to take basically MR. MR in this triangle is opposite to theta angle. So we will take MR, and in the other triangle, is the smaller triangle. Again, what is the side opposite to theta? This is theta. So MPM is the again side opposite to theta, right? So this is what we got. So we can write again cross multiplication. We can write PM square equals to MR into QM. This is what we had to prove, right? So we got it. So if you guys have not understood how we got this angle 90 degree minus theta and how this theta, let's do this part again. We'll call angle Q plus angle QPM plus angle QMP equals to 180 degree. In a triangle, all these three angles will sum to 180 degree. I'm calling Q as theta, and QPM we need to find out, and angle QMP is 90 degree. So this is 180 degree. So QPM will be again it will be 90 degree here, and then theta will come over here. So 90 degree minus theta. So this is how we got this 90 degree minus theta as Q2, right? So this finishes our second question. Now let's move on to the third question. Alright, let's move on to the third question. So what is my third question? Third question is this. In third question is saying, in figure 6.53, figure is already given. AB is a triangle, right angle at A. So basically this angle is my 90 degree, and AC is perpendicular to BD. Again, AC is perpendicular to BD we are getting. We have to show that AB square equals to BC into BD. So we'll do the same thing what we did in the first example, in the previous example. So let's first write out what is given. It's given AB square equals to BC into BD. This is what is given. Can I write this as AB by BC equals to BD by AB? We can write that, right? I've just did a cross multiplication. Now looking at this expression, we can figure out which triangles we have to work with. So AB and BC. So we are getting AB over here and then BC over here. So this triangle, smaller triangle looking at, and BD and AB. So we are getting BD. This is a bigger triangle, and then AB, again the bigger. So it is looking like we need to deal with this smaller triangle and this bigger triangle. And as we have discussed earlier, we know that triangle BAD would be similar to triangle ACB, right? We got to now see again the angles part. So if we call it as theta, we know that this angle is my 90 degree minus theta, which is 90 degree minus theta. So this angle is theta, and since this angle is theta, this is 90 degree. Again, this angle is minus 90 degree minus theta. Alright, so now let's work with triangle BAD. When we are working with triangle BAD, we know that we need to get AB and BC. So we need to get AB. So AB is opposite to AB is opposite to what? AB is opposite to 90 degree minus theta. So in this smaller triangle, what is the opposite to 90 degree theta? Is BC. So we'll write AB is to BC. Similarly, we need to get BD. BD is opposite to 90 degree. So this is BD. We'll write BD. And then we got to work with what is opposite to 90 degree in this, which is AB. So this is AB. So from similarity condition, we can write that since these two triangles are similar, the sides will be in this ratio. So we got this first part. Now let's work with the second part. What is my second part, which is talking about AC square equals to BC into DC. Now again we'll do the same thing. What we'll do is we'll put AC is to BC and then DC is to AC. I've just did a cross multiplication. If you don't understand, AC square is written as AC into AC, right? So this is what it is. Now look at this AC BC. We have got AC, we have got BC. So we have got this smaller triangle. We have got DC, which is again this side, and we have got again AC. So looks like we have to deal with these two triangles, and as we know, these two triangles are also similar. So we'll write triangle ACB is similar to triangle ACD. This implies that in this triangle AC, which is opposite to theta degree, so AC divided by what is opposite to theta here is CD. So we'll write AC upon CD or DC, whatever it is, equals to, we have to get another one as BC because DC we have got BC. So BC is opposite to 90 degree minus theta. So we'll write BC, and then what is opposite to 90 degree minus theta over is AC. So we got AC over here. So again we'll do a cross multiplication like this. So we'll get AC square equals to BC into CD or DC. You can write BC or DC, BC into DC. Right? So this is what we had to prove. The second one is also done. Now let's work with the third one. Third one says AD square equals to BD into CD. Right? Now again what I'll do is I'll put AD by BD equals to CD by AD. So this will again let me understand what triangles we are dealing with. So AD and BD. So AD is this and BD is bigger one, looks like. CD is this and AD is this. So bigger triangle and then ACD triangle we are dealing with. So again we can write triangle BAD is similar to triangle ACD. When we write that, we can write this now. So in AD is this bigger triangle. If we are looking at this bigger triangle, we are getting AD, which is opposite to theta angle. So we'll write AD, and then in the smaller one, again what is available against theta, which is CD. So we'll write CD, and then we have to work with BD because BD is there. So now BD is opposite to what? 90 degree. So we'll write BD over here, and then we will have to write what is opposite to 90 degree, which is AD. So we have to write AD. Now do a cross multiplication. Again you get AD square equals to BD into CD. So yeah, this is what we had to prove. So yes, all these three questions are done using the similarity condition. Then since these triangles are similar, then we have arrived at these results. So yeah, so we are done with all these three problems. We'll discuss all the other problems in the next class. Alright, thank you so much.